So our final video here is going to look at fuel cells, and fuel cells use the energy from a specific reaction, the reaction of a fuel with oxygen. So a fuel with oxygen, so basically combustion, to create a voltage. So rather than burning methane to make carbon dioxide and water and a big flame, we're burning the fuel in a way that will allow us to create a voltage rather than light and heat. So we're trying to capture the electrical movement. So the fuel and the oxygen are going to flow into the fuel cell, but they're flowing in to separate halves, so separate half cells, so that they're not going to set on fire with each other. They're flowing into separate half cells, and the products will flow out of our fuel cell, but the electrolyte, the thing that's going to balance the charge, is going to remain in the fuel cell. And in this fuel cell that we're going to look at, we're going to be using an alkaline fuel cell, so our electrolyte is going to be the alkaline, the hydroxide ions. Now these can continue to operate continuously as long as you keep pumping fuel and oxygen in, so you're not going to use them up, you keep pumping them in, so they will not need to be recharged. So as long as you keep putting fuel in, then your EMF over time, so unlike a regular battery, it's not all in there at the start, you keep adding it, the EMF over time will just stay exactly the same. So try to make that line a bit more flat. Okay, so the EMF will stay exactly the same. So what does it look like? Well, it looks a little bit like this. Again, you'll be provided these equations by the exam board. So it has two electrodes, because obviously we've got two half cells. Now, if you look at our species, is there anything in there that could be used as an electrode? And if we look, we've got no solid metals. So just like in our other cases, we're going to use some platinum as our electrodes. It's going to be porous. Porous meaning like have holes in it, so increasing the surface area. Okay, so the cells of the two electrodes has two electrodes of platinum. They're separated by a semi-permeable membrane. That's going to be like our salt bridge. It's going to allow certain things across, but not everything. And the electrolyte is going to be our alkaline, which in this case will be something containing hydroxide ions, so for example, sodium hydroxide. So hydrogen is going to enter, so let's find hydrogen in our equations. Here's hydrogen, so let's have a look at it. Is that the negative electrode or the positive electrode? Is that the more negative value or the more positive value? Well, it's in the more negative value, so hydrogen enters at the negative electrode. And if it's the negative electrode, what do we do to the half equation? So because it's the negative, we're going to reverse it. And this is what happens at the negative electrode. So hydrogen enters and reacts with the electrolyte, the hydroxide solution, to make some water and release electrons. Make sure I put the right number of electrons there too. The electrons are then released. They go into whatever it is we're trying to drive. So in our picture it's lighting a light bulb. The electrons flow from the negative electrode on the left, where the hydrogen enters, flow to the positive electrode on the right, where they're released. So they flow to the other electrode, where the positive electrode, where the reaction with the more positive value occurs, which is that. Now we need to combine those to get the overall equation. Now, if you look at that, we're going to combine them. We're going to need to double up the top one, because we need to have them both having 4 electrons. And so overall, we're going to get 2 hydrogens plus, if you double this up, you're going to get 4 OH minuses, which is going to cancel with, so if we double this, we're going to get 4, which is going to cancel with these 4, so we don't need those. So we're just going to add the O2. If we have 2 waters here, we're going to double this up, we're going to get 4 waters. So overall, we're going to have 2 waters left over. Now, if you need to write that out in more steps and then cancel things down, you do that. That's a better way to maybe go about it. But if you look at this equation, what have we overall got going on? We've got hydrogen, our fuel, reacting with oxygen, and on the top line, we said a fuel cell takes the reaction of fuel, hydrogen with oxygen, and uses it to create a voltage. How would you calculate the EMF? positive minus negative, and we get 1.23 volts. And then our final bit, what are the advantages and disadvantages of fuel cells over other cells or over using cars? Well, they are more efficient. So the stored chemical energy that is stored inside those chemicals, more of it is converted to electrical energy and then converted into kinetic energy than would be in a regular car. So if we were using a petrol-driven car, more of the energy from the chemicals ends up driving the car in a fuel cell than does in a regular car. And because we're just producing water, there's no CO2. The only waste product is water, so we're not burning carbon-based fuels and making carbon dioxide, contributing to global warming. And they produce a continuous supply, so they do not need to be recharged. What are the disadvantages then? Well, you've got to get the hydrogen, and hydrogen is produced by the electrolysis of water. Well, electrolysis requires quite a lot of energy, and that energy tends to come from burning fossil fuels, so you're circumventing burning fossil fuels in your car, but you're burning fossil fuels anyway. Hydrogen is a highly flammable gas, and it has to be handled very carefully. So it's not that easy to transport. And also there's no infrastructure for hydrogen fuel cell cars, and what we mean by that is you might fill up your car with hydrogen at the start of your journey in your house. By the time you've driven halfway down the M1, you've run out of hydrogen, you pull into the service station, there's no infrastructure, there's no hydrogen fuel cell refilling, and therefore you're stuck. So until there is that infrastructure, people won't move to hydrogen fuel cell cars.